recorded. And some of you might have noticed, because you might have subscribed to my channel. Yeah, good morning. So you might have subscribed to my channel so that you know that I'm picking up a new class, CISW410, which is the title is middleware scripting, which is basically just web scripting, which is basically using a program to generate HTML documents on a server in response to an HTTP request. I mean, that's the most technical way to describe that class. So, if you have spare time, you're more than welcome to watch, that series of videos. Um, but it's interesting how I just got a new class over the weekend. Yep, it's another 4-unit class that I got over the weekend. And this one, I have some preps for it already. I know fairly well how to do web scripting. Um, it doesn't translate to having everything ready in Canvas, so I'm still constructing the material as we go in that class. So this is going to be a fun semester for me. Last semester I got a class dropped on my lap close to the end of the semester. Yeah, that was interesting too. That was interesting too. And in both cases, we have an adjunct colleague deciding either to resign or basically not to teach a class in the middle of the semester. Yeah, that was web scripting basically. So I'm teaching the class how to use Node.js, which is a form of JavaScript, to write scripts on the server in response to HTTP request. So basically just web scripting stuff. But we'll get into how to use MySQL as a database to supply the data. We'll talk about how to use potentially promises and whatnot. Yes, I noticed. I noticed, Vlad. And that class has a very different quote unquote clientele compared to CISP310. Because many people in that class had never written a line of code before. Unfortunately, a programming class is not a prerequisite to get into CISW 410, and that makes that class a little bit challenging to teach because just telling people how to sign into the server and perform various um, command line activities on the server can prove to be a little bit of a challenge already for that class. And we got 2 people typing. So this is still before class time, so we can talk about anything. Oh, the multi-bit stuff? Yeah, I can do that. Um, yeah, might as well use this time to open that up. All right. I think I just scrolled past it. There you go. All right, so I'm guessing you guys want to use to be able to review the content so we can study. So we'll go ahead and click that on. And that should do it. Let me save it and see if. All right, so there you go. If you refresh, Daria, if you can refresh, you can tell me whether you can see the content or not, or the content of the multi-bit stuff lab. All right, we got 30 seconds to go. Okay, excellent. Thank you for confirming. All right, so we got 30 seconds, 25 now. If you're watching YouTube, we probably only got like 15 because of the lag. We got 4 people on YouTube on the YouTube side, and a bunch of people on the Discord side. So my focus is going to be staying on the Discord chat channel while we talk about the practice exam. All right, it's time to go to get started. So I'm going to share with you my mind map for the day, and we're going to start with the review of the exam review. Based on my personal experience going through college, it is really a courtesy slash service provided by the professor. Because, as far as I can remember, I don't remember having exam reviews when I was in college. And I went to San Francisco State University, the University of Hong Kong, and UC Davis. Now, UC Davis is a little bit different because it was a graduate school. So, you would probably expect graduate students to go like, yeah, just throw exams at me and I'm ready all the time. No, I'm just kidding, but it is a different type of context in that case. All right, second one is how to get the most out of a practice exam. So the first thing is I would suggest people to study as if it is the real one. In other words, really try to study as much as you can and then take the practice exam. So this way you can really assess your preparedness to answer the questions. So that is kind of important. Okay, so Terrence has a very good question. The answer is you're supposed to type your answers in the exam document itself. Now, it doesn't mean that you cannot use extra sheets of paper to help you get the answer, but I cannot use the extra sheets of paper even if you upload it to the server as part of the answer. So, that is the restriction, because I found that, when people use, just pieces of paper, it becomes really difficult to grade because there's no conformity of the format, so I'm going to have to specify the format in a much more confined way. It helps with the students too, because now the degree of freedom is a whole lot less compared to just saying, okay, just do whatever you want to answer these questions. So now I'm going to go like, okay, you have to use this particular format and use this particular language to answer the questions. So that's a very good question. It's not a text editor. As I go through the practice exam, that's exactly what you are going to do with your exam next Monday. So once again, the exam is next Monday. Oh, no, I take it back. I lost track of time. Next Tuesday, okay, starting at 9 a.m. Man, I just lost track of time. All right, so getting back to getting the most out of a practice exam, is first study as if it is the real thing, and then try your best to answer the questions. Even if the question looks like, I have no idea what to do with this. Okay, okay, I'm not going to do that. But if someone, look at the exam and go like, what is this? Okay, I have no idea how to answer the question. Don't walk away. Just kind of stay with it and just try to understand what the question is asking, and then try to figure out what knowledge that you have learned in this class is going to be applicable in, and then try to kind of piece together the reasoning to connect the knowledge that you have already acquired so that you can go from the question to the answer. So I'll describe that whole process as I go through the exam. And as you go through the practice exam and you go like, this part I don't really quite understand, or this part I'm really kind of stuck. I can work up to this point, but then I'm stuck. Jot down those questions. Okay, even if you don't ask the questions during class time, I have office hour, right? My office hour is right after the lab time, on Tuesdays and Thursdays. So the interesting thing is very few people make use of my office hour. So, that's actually a resource that you guys can use too. So I think that's enough nagging. And now we're moving on to your specific exam next Monday. Tuesday. I keep saying Monday. Next week on Tuesday. There we go. All right. So your exam is guaranteed not to have any duplicate questions from the practice exam. So I'm saying this specifically because I don't want people to over study, to over practice using the practice exam. That's one of the things that can actually hurt, is to over practice, because when people practice, instead of increasing the agility of your mind to problem solve, it becomes mechanical, and that's actually dangerous in this class. At least the way I ask questions, because it builds up a certain momentum. Okay, it's kind of like a train, right? The more you practice, the faster the train goes, and the more practice, the faster the train goes. And then here comes a bend, and the train is going at full speed. Not gonna be very good. Okay, so what you need to do is to just get all the knowledge, get the techniques, get the skills, okay, get the reasoning behind how I answer these questions, or how you already answer the practice and exam questions, and then just let that be the result of your practice exam. Okay, because the more you practice the specific steps to get to the answers in the practice question, the faster your train is going. Which means it cannot handle a bend anymore. And I can guarantee bends in this case in the exam. So that's a little bit of a advice. People can take it or leave it. The format itself may or may not be similar or the same. So I'm still trying to work out what questions to ask in the exam. But what we know for sure is the scope. Okay, so the scope part is determined. So we are going to have everything up to and including binary number comparison. So we know, what content, what material is going to be in the test. So this is just a quick rundown of all the concepts that I can remember from the modules and also from the lectures. So it's not just coming from one of the two sources. Okay, if I talk about something in lecture, it can be used in the exam. If it is in one of the modules that is written and linked from Canvas, it can be in the exam, even if I did not talk about it in a lecture. So you kind of have to make sure that you cover both the written side and also the spoken side. All right. Well, Daniel, you just have to wait and see what we are getting to. I mean, we are. Oh, by the way, you can also go to YouTube. This is one great thing about YouTube live stream is you can go to the live stream, and I believe you can drag the time bar back to the beginning. Obviously, that is not a very good advice in this case, because if you did that, then you'll be missing what I'm talking about now. So there's really no quick and easy way to catch up until after the lecture. Um, that's kind of the deal here. Um, so this is the general scope, okay, of the exam, and this is just an outline, okay. It is not an exhaustive list of all the things that we have talked about. This is just identifying some of the more important ones. So for the details, you still have to get to the module and also potentially rewatch some of the videos. And this is why taking notes is important, because your notes is based on my lecture. And if I talk about something in the lecture, you're going to take notes, so you can just go back and review your notes. You don't have to go back and rewatch the entire lecture. Now, for certain portions, you go like, okay, I can't take notes that fast, okay? But if you put in a timestamp and a date, next to your notes, you can always go back to a specific video and just review it in, it's just play and then pause, play and then pause, and then play and then pause. Then you can, basically capture all the notes for that particular topic. So all of these are things that I have talked about from the very beginning of the class. Is that you have to take notes in this class. If not for anything else, just make your own catalog of when I talk about a specific topic. I also find having a centralized place of all the definitions can also be helpful, okay? But that's also just my suggestion. Some people may not need it, okay? Some people can track all of that in their head. That's okay, not a problem. But in general, I think it's a good idea to jot down those notes. Logisim is available to you, but I don't think I'm gonna ask any question that involves the use of Logisim. So if you think you can make a circuitry out of Logisim or reuse one of the circuitry in Logisim from before and you think that's going to be helpful, you are welcome to do it. Basically anything other than collaboration or live help or interaction with another person other than myself during the exam, everything else is okay. You can use Google search. Not a problem. If you want to rewatch my videos during the exam, not a problem either. If you want to if you want to read the modules during the exam, not a problem. If you want to revisit the lab during the exam, not a problem. If you want to watch or if you want to read the practice exam during your actual exam, that is also not a problem. Okay, so the only problem I have is with collaboration, people working with other people live, in with interaction. Um, that would not be okay. So I'm pretty lenient when it comes to what resources people can use, um, as long as the result is indicative of the academic performance of that person alone. And Google searching is not a problem because I have a tendency to ask questions where the answer cannot be Googled. Yes, after a day, we will talk about the exam. Depending on how much time we have in the lecture, sometimes I would record that conversation or record, the way I explain the answers and then just post it on YouTube. And then in the following lecture, if people have questions about the video, we can talk about it. If not, then we save some time in our actual lecture. So that's a very good question, Jonathan. Alexander is also typing something, so I'm gonna wait a little bit. Okay, and Jonathan is typing too. All right, so the question from Alexander is the group ABC grading system on the practice exam also used in the exam next week? Let me point back to something that I have kind of talked about already. The format may or may not be the same. So the answer is I don't know. It's up in the air right now. So don't count on the format of the test. Okay, when you get your test, make no assumptions that it is similar, it's going to be about the same as the practice exam. Just treat it as an exam that you have never seen before. Okay, do not make assumptions. Assumptions are your worst enemies when it comes to taking my classes or exams. All right, so getting to the last portion before we actually get to the practice exam is how I grade. Okay, so because if you know how I grade, I hope that will help you determine how you would want to answer the questions. The first one is it is not effort based. I have heard from people from past semesters that I studied really hard for this test, I used this much time, and so on and so forth. But I'm getting this grade. Is there any way I can get a better grade? The answer is no, because the grade is not effort based. It is based on the evidence of one, the understanding, and two, the ability to apply the knowledge that we have learned in this class related to the subject matter. Okay, so I just want to make this really clear, before the exam. Okay, so now the question is, how do you demonstrate your understanding of the material and your ability to apply the knowledge to solve problems in this class? So that becomes the real question here. So there are, for every question, for every rubric, I use A, B, C, D, F, basically based on your GPA system, to rank the answers. And A is pretty easy. It's a perfect answer. There's strong evidence of the understanding and the ability to apply the knowledge in the case of an A. It's a perfect answer. Nothing wrong with it, and has the evidence of the understanding and the ability to apply the knowledge. A B, on the other hand, is almost perfect, which means there are either some minor omissions or some minor mistakes. And these mistakes are quote unquote careless mistakes. meaning that they're not conceptual. Somebody is not, putting in or using the wrong concept to try to answer the question. It's just the right concept, but during the application of that concept, a mistake was made. Okay, it's a manual mistake, copying a 0 instead of a 1, or something along that line. Otherwise, there's strong evidence of the understanding and the ability to apply the knowledge. That is a B. A C is enough evidence of sufficient, in quotes, understanding and ability to apply the knowledge, but just barely. Okay, so a C basically means there's probably more omissions and more mistakes compared to a B, but the most important part is in a B, the mistakes are mechanical, and in the C, the mistakes are conceptual. So, and that's kind of the main distinction between the B and the C. And also the quantity of mistakes and or omissions. If there are plenty, it's going to be a C. If it's just kind of minor, it's going to be a B. So there is a certain subjectiveness, to differentiate between the B and the C. Between the C and the D is whether there's sufficient evidence or not about the understanding or the ability to apply the knowledge. And then the D is no evidence whatsoever of the understanding of the material or the ability to apply knowledge. So there you go. So that's the ranking. So let me ask you guys a question. If I ask a certain question and somebody just gives me the final answer with no steps whatsoever, no evidence whatsoever in between, what grade would that answer deserve? Probably a D. Depending on the context, it can even be an F. Okay, because if I look at that question, and go like, yeah, this is something people can just Google for the answer, then in that case, I might even just drop it down to the F. Okay, because it shows no evidence whatsoever, right? Even for D, there's just insufficient evidence, which means there's some evidence. But if somebody just to write down the answer, there's no evidence. There's evidence that that person can get the answer, but there's no evidence of any understanding or ability to apply knowledge to get to the answer. Yes. So you might, yeah, exactly. So Daniel is correct. I want to see evidence of your thought process and what knowledge that you have already gained and what knowledge you're applying in order to solve the problem. So even if you just kind of lay out the knowledge and not really solve the problem, that's partial credit already, because there's evidence of at least your understanding and go like, I know this kind of knowledge is going to be helpful to get to the answer. There's some evidence, right? As opposed to no evidence whatsoever. All right. So there is that. And then we are going to move on to the actual exam unless there are additional questions. All right. Yeah, we're going to do. Oh, okay. Jonathan beat other people to the punch. Can we do number one first? I think it's a good idea to do number one because it is the most difficult one. But once we get to number one and once I explain number one, the rest are going to be easy. And then Daniel asked, and we will be submitting this evidence along with our evidence inside the text editor. It's Google Doc, okay? So let me proceed with the actual exam, and now we can see how you're supposed to answer the exam. All right, so I'm going to bump up the font size first. Okay, that is large enough. Okay, so Terrence said, I'm hoping for a lot of examples of how we explain our answers and show our work. Okay, very good. That is totally understandable. And I'm going to show you, a way where you can just refer to a key. In other words, you just explain a few things and then you just refer to that as, okay, that's rule A, that's rule B, that's rule C, and so on. So now you can, just kind of shorthand your answer to refer back to those things. Um, do we have a copy of this exam? You're not finding it on Canvas. Let me see if it is already shared to. All right, so I can share this with. I'm gonna share this with people in the Los Rios Community College District, which means you need to sign into apps.losrios.edu first before you have access to this document, and then I'll post the link over on Discord. So this way you guys can follow along when I work on this. All right, so there you go. All right, so I just posted the link to this document on Discord. So if you click on that link after you sign into apps.losrios.edu, you should be able to see the document live as I edit it. All right, so there you go. All right, so since someone suggested to go for question number one first, we're going to go for number one first. So number one is asking, okay, the first part is to figure out all the unknown bits marked as question marks. The sequence of figuring the unknown bits must be self-contained in this answer, which means it has to make sense, and the answer itself would also imply the ordering of how these bits are figured out, and not reliant on the answer of another question. For each bit, so don't refer to another question and go like, okay, this is similar to question number 2, and here's the answer. For each bit, clearly states which bit, its value, and how you use the definition to derive it. As an example, you might say, oh, I can figure out T2 now. T2 is a 1 because T2 is the exclusive OR between X and Q, and at this point X2 is a 1 and Q2 is a 0. Now obviously that is a very long way of explaining things, so I'm going to show you guys how to kind of shorthand it in just a little bit. Now this is utterly wrong, okay, because Ti does not depend on Xi, Qi, and it certainly does not depend on exclusive OR. So I am using this just an example of the format of the explanation. By itself, this is totally wrong. In other words, this particular answer will get an F because it has no evidence whatsoever of the understanding of the concept of what is a T2, what is a T bit, how it relates to the other bits, and so on and so forth. So it would actually get a 0 in this case because the answer has no evidence whatsoever of the understanding or the ability to apply the knowledge of binary subtraction. So that's a very good example. You may update the unknown bits of the subtraction in place, but the explanation must be sequential. The order, if the order does not make sense, points will not be earned. In other words, if somebody just somehow figure out the bits and then just in the text go by, oh, this is X, X1 is like this, Y0 is like this, Y1 is like this, Y2 is like this, in that particular order, that person will probably get a very low score because that doesn't explain the reasoning. Because if people are using the correct reasoning, that would not be the ordering of how the bits are figured out. So I'm just reading the question, to make sure that people do understand, what I mean when I say, the ordering has to make sense and so on. Note that the unknown bits can be from X, Y, Q, T, D, as well as the overflow and the less bits. So if you go back to here, the unknown bits can be in all of these rows, X, Y, Q, T, D, and it can also be the overflow as well as the L bit. Okay, this is actually lowercase l, it is not a 1. All right. Yeah, exactly. Yeah, exactly. So what Richard wrote is correct. You guys need to state how you get the value of a particular bit, and connect your method back to the definitions of the bits. All right. So and use this area to explain how you get the unknown unknown bits resolved. A bullet list to make the answer easier to read. Alright, so this is what I'm going to do, and to make it easy to differentiate where's my answer and so on, I'm going to turn on, I think it's this icon here, nope, wrong one, There is, oh, right here. Okay, I always forget because I don't use it very often. So I'm going to use the suggesting mode, which means that whatever I type now is going to be in a different color. So it makes it very easy to differentiate between what I type now as opposed to part of the question itself. So I'm going to use a bulleted list, okay, like so. And then we're going to go take a look at this and go like, okay, where do we start? Right? Okay, so right now, um, what I would imagine people would be doing is to reach into their knowledge toolbox and go like, okay, what do I know about the relationship between all of these bits? Okay, so we know how x, y, and q are related. That's through exclusive OR, and that's all the same with between q, t, and d. So that's the easier part. But the t bits are a little bit more difficult because the t bits relate to both x, y, and qt of the previous column. So this is a good time to kind of retrieve what you know about those specific rules. So I'm just going to type it here, and I might move things around a little bit. So I'm just going to write down what I know about the relationship of the bits. Okay. So I might even label these things. Okay, I'm gonna say rule A. Okay, this is just because I can reuse the rules. Okay, because I can just specify the rules, and then in the next question I can re-specify basically the same rules, either copy and paste or refer back to see rule definitions of question blah. Okay, so that is actually okay because that's not part of the actual explanation. It's just a key to what rule A means. All right, so Qi is Xi exclusive OR with Yi. Rule B, let's do the D bit, okay, because it's very similar to the Q bit, except it depends on Qi exclusive OR with Ti. Rule C, it would be the T bit, okay, T of I plus 1 is not Xi Yi, or so you can use regular OR, you can use the plus, you can use a bar, it's up to you. As long as I can read it, it's okay. So you can choose any format as long as it is one of the format that we have used in class. So the other one would be the negation of Qi and Ti. That's it. Okay, so Ti is right here. It would be helpful because you can refer back to the rules instead of having to rewrite the entire rule all the time. So that's kind of up to you. The other thing potentially you can also do is to say instead of rule A, you can say this is rule Q. It's up to you. I mean how you want to name the rules because. All right, so rule D is going to be dealing with the overflow flag. So the overflow flag in this case is, since we know the number of bits is 3 bits, so we can define the overflow as the negation of x2, y2, and then d2, or non-negated x2 and negated y2 and negated d2. So this is just knowledge, okay? Knowledge basically translates to stuff that is mentioned in the modules and or the labs and or the lectures, okay? It is not application. Right now I'm just regurgitating, or I can be looking up my notes, okay, during the exam and go like, okay, this is what I know about binary subtraction, how the bits are relating to each other. And then there's also the last one, rule E. Actually, there are 2 more. The sign bit is D2 just by itself, and then rule F in this case would be the L flag. So the L flag, okay, and I'm going to use uppercase L here, just so that it's easier to read. Richard says, I declare a definition / rule in a question. Can I refer to it again? Yes. The answer is yes. You can always refer to it. You can just say, okay, see definition of rules in the answer of question blah. Okay, so we have L. L is the overflow exclusive OR with the sign flag. All right, so now we got everything down, okay? And if anyone is looking at these rules, these 6 rules, and go like, I have no idea where these things come from, um, okay, I'm gonna let the rest of the class suggest what to do next. Read the modules, rewatch the videos, um, and don't go too fast, okay? Because it's not about memorization, it's about extracting the knowledge out of all that stuff. Call a tutor and pray. I'm just gonna use that as my response. Yeah. Okay. So, what do we do now? Now we go back and say, what do we actually know? Okay. So we know there's a 1 here, but how do we determine y, q, t, and d? Probably no way to do that. We have a 0 here, but we cannot use this 0 really to help us to determine any of the other bits. So, and the overflow is also unknown, the L flag is also unknown, so we have no suggestion of what this bit really should be in relation to x2 and y2. But the strongest clue we have is T3 being a 1. Yep, yep. So that's where we start. That's very good. That is where we start. We know T3 is a 1. Okay, so we'll go ahead and type the answer. So T3 is a 1, and this implies. Um, so I'm going to use. Okay. So using rule, which one is it? C. Um, So using rule C, we know that T. So basically, you pick up a rule C, and then you substitute I with 2 in this case. So now we say the negation of x2, y2, or I'm using plus instead of or because it's easier to type, and negation of q2, t2 is a 1. Okay. So is that okay? Does everybody understand why rule C is applicable in this case? Because we know the T3 is a 1, and according to rule C, that can help me understand that this particular expression has to be a 1. Is that part understood? Because this is how we solve the problem step by step. We start with the knowledge, which are the rules A to all the way to F. That's part of what we already know from the class. But we also know T3 is a 1 because that is in the question. And then we use that and go like, okay, so that implies a bunch of stuff here. So once we have this bunch of stuff, okay, then we also say, of all of these terms here, Q2, Y2, Q2, and T2, what else do we know? We know what X2 is, okay? So we say, but X2 is a 1, so that implies not X2, Y2 is going to be a 0, which further implies not Q2, T2 is a 1, which further implies Q2 is a 0, and T1 is a 1. Oops, T2, sorry. I typed incorrectly. There we go. So that would be a B answer because I copied incorrectly. Careless mistake. So you can probably infer that, if I keep up with this kind of carelessness, the best I can do in an exam is probably a B. So you can tell other professors and go like, yeah, Tech is a B professor. He's not an A professor. Anyway, so now we have just got a few bits resolved, didn't we? So we know that we don't really quite know what y2 is from this particular equation, but that's okay. We figure out what is q2 and t2 right here, which is going to be a great help, okay? Because you will see why that is a great help. So instead of just backfilling here, I am going to copy and paste because that really helps to establish the context for the steps that are following. So I don't have to basically just scroll back and forth all the time. So I'm going to go here and use a unbulleted list area and paste the all the bits here. And because of this, I have just resolved what is Q2. So Q2 is right here. It is a 0, and T2 is a 1. So far, this is what I have resolved. And go back to the bulleted list. There we go. Okay, so in the text channel, I have a few comments. I'm confused. I thought we do not have to explain the givens. I did not explain the givens. I was using the given, which is what x2 is already is. I'm using it to infer the expression of not x2, y2 has to be a 0 because x2 is a 1, not x2 is going to be 0. 0 and whatever is going to be a 0. So that is what I did over there. Next one is I understand the concepts, but the rules make it confusing. Well, you mean the rules A to F? That's just regurgitating, restating what we already know from the modules. The application of the rules is going to be the part that is kind of interesting. So this symbol here means implies. In other words, given what is on the left hand side of the implication, we know what has to be true on the right hand side of the implication. The next one is 2 used because I plus 1 equals to 2? That is no, because 2 plus 1 is 3. Because this is how we got started here. Okay, this 3 is the I plus 1, and therefore I equals to 2. The rules are just all the concepts written out so we don't have to constantly retype them. That is correct. So Terrence is correct. This way I can just refer to a rule instead of having to retype the entire thing. Daniel says, seeing the rules in this manner actually seems like it could help with understanding. Well, this is what you're supposed to have done when you take notes. That is what I have been telling you guys to do, is to extract all the definitions in one spot, which is what I have done here. All right. Oh, okay, my alarm just went off, which means it's time to take roll. All right, so we are going to take a break from this and take roll first. All right, so here is the roll taking activity. I will show you the answer. All right, so the answer is x1. Come on, show me. There we go. So the answer is just lowercase x and then a 1. I put it into the text channel, and let me save and publish so that you guys can participate in this activity. I hope BMW is not going to sue me for infringing on the model name of one of their cars. X1 as a model. As a model name of a SUV. I'm not really so sure about that as a good idea. Because when people go with SUVs and whatnot, they want 4x4, right? So X1 is kind of like 4x1. You mean out of the 4 wheels, only one is actually having torque, having power. That doesn't sound like a very good design for an SUV. I'm just kidding. I know why they name it X1, but still. And as far as I know, there's no X4 either. There's X1, there's X3, there's X5, but there's no X4. So they haven't made an SUV out of the 4 series. Those are X6. Okay. I'm certainly not rich enough to own a BMW, but none of my neighbors is rich enough to get an X6 either. Oh, okay, so they have an X4 now. There's also X7. Yeah, my entire neighborhood is not. There's no one in my neighborhood rich enough to go anywhere beyond a used X5. And X-Men. Oh yeah, that's funny. Nope, I do not own any crypto. All right. All right. So getting back to the question. Thank you, Jonathan. Is that valid? Q2 is 0 and T2 is 1 because B of x2, y2 is guaranteed to be a 0 because x2 is a 1 and hence b10 is a 0. Well, we don't know whether that, we don't know what y2 is, right? Because we can only infer what y2 is after we know what q2 and t2 are. Or we can, well, q2 is going to be important, right? We need to know, what is q2, and then combining that with x2 we can infer what y2 is. So at this point we don't really know what y2 is, we just know it is something, but what it is doesn't really matter, because if x2 is already a 1, then not x2 is already a 0, which means the conjunction between not x2 and y2 is guaranteed a 0. uh, Okay, so let's proceed. Okay, so Jonathan is one step ahead of me in terms of the answer. So from now, we can now say, okay, what can we do now? There are a few quick things we can do. So we can say, using rule A, okay, we know that y2 has to be a 1, okay, because x2 is a 1 and q2 is a 0. All right, so now we can go backfill this one and say this has to be a 1. And also we can determine what is D, but I'm going to use a different line to document it. So now we say, using rule B, D2 is also going to be a 1 because now whether you write because or use just kind of mention that this is what we know up to this point. So Q2 is a 0 and T2 is a 1. That is why D2 is a 1, because of rule B. There we go. So now we update D. So I don't copy and paste the entire thing, because if I don't need to, I just kind of just leave it as is. I only copy and paste when I need to go I need to scroll back and forth, then I'll copy and paste it. So this one is guaranteed to be a 1 now. All right, so now what do we do, right? As it turns out, the carry bit is actually very important. We can actually determine what is O by now. Okay, so we can now say rule D. Okay, using rule D, we can now determine what is O, and it's going to be 1, 1, 1, so it's going to be a 0. Okay, and this is fine, if you don't quote the entire thing and say because bit x2 is a 1, y2 is a 1, and then d2 is also a 1. There's no need to mention it because I can see it, right? So if you use this particular way and basically refresh your all the bits, when you explain it and say which rule you're applying, you don't have to quote, okay, because x2 is a 1, y2 is a 1, d2 is a 1, because it is, reflected over here. And the ordering of getting the bits figured out is correct also. If someone is to give me, O is a 0 before we determine D2 is a 1, that would be the wrong order, because we cannot determine, well, we can, but in that case it has to be a more detailed explanation. Because if in a conjunction at least one component is a 0, the whole conjunction is a 0, but it would not be as obvious as what we are doing at this point. All right, so getting to the next one. So this borrow bit is a 1, and there's a 0 here. So let's see if we can use that to determine anything. So now we are reusing the borrow bit rule. So now I have to scroll back and forth again. So here's a trick. Okay, you guys all have a larger screen because you're using I'm using a 1280, and I'm also zooming in. So one trick you can do is to copy the URL. You cannot see that I'm copying the URL, and then open a new window. So I'm using the browser to open a new window, and in the new window I paste exactly the same URL. as the one that we are working with right now. So I end up with two windows of exactly the same document. So you can see, the one on the right hand side is really the same thing. And you can even have a different editing point, which is the whole point here. Because I want this one to stay with the rules while using the other one to refer to the rules. So this way, I don't have to go back and forth to look at, okay, which rule is the borrow rule, okay? Because I can now look at on the right hand side, which hopefully on your screen would not be overlapping, the other window. But that makes it a little bit more streamlined when it comes to answering the questions. So that would be rule C. So according to rule C, knowing that T2 is a 1 implies the negation of x1, y1, or the negation of q1, t1 is also a 1. And then knowing y1 is a 0 implies. Okay, so let's see what it is going to imply. It implies not x1, y1 is going to be a 0, but because we know the OR between these two terms is a 1, and we know one term is a 0 already, that leaves us no choice but to conclude that q1, t1 has got to be a 1, which in return implies that q1 is a 0 and t1 is going to be a 1. Are there any questions about this particular line of reasoning? All right, cool. So we know Q1 is a 0, T1 is a 1, and that in return, would help us to determine what is X. So I'm going to move my window to a place where it's not overlapping, so I can actually refer to the rules. So now I can say using rule A, we can now determine that x1 is a 0, and at this point we can use rule B to determine that D is a 1. So D1 is a 1. Whoops. D1 is a 1. There we go. Alright, so I'm going to go back and backfill this. So this is going to be a 0, and this is going to be a 1. Alright. Now what do? We look at this and go like, ha, we have done this already, right? Because this is actually resembling how we resolved bit 2, the column of bit 2. So at this point, you can basically say, using the same technique to determine bit 2, the column of bit 2, we can now basically say, y, it's the same deal. Okay, so y 0 is going to be a 1, q0 is going to be a 0, t0 is going to be a 1, and d0 is going to be a 1. In other words, what we did, based on T3 to figure out all the bits in column 2, we just basically say, yeah, we're doing the same thing over here. So this is a 1, then we got a 0 here, this is another 1, and this is another 1 here. Oh, by the way, we figure out the O bit already, so we can, I forgot to populate the O bits. Right, so the O bit is determined to be a 0, and once we determine the O bit and we know the sign bit, which is a 1, we can also determine that. So that can go here, but I can also put it at the very end because I forgot to put it there originally. So we can now refer to rule. What is the sign bit? Sign bit is E. So using rule E and F, the L bit is the O bit exclusive OR with D2, and both of those are known already. The O is a 0, and D2 is a 1, so that means the L flag is going to be a 1. So go back and fix that one to become a 1, and now we have the full answer to this particular question. Alright, so let me go back to the text channel to kind of catch up with the messages. I put D2 as 0. D2 is a 1. Oh, this 0 is not referring to D2, it is referring to the result of the exclusive OR. So let me put in extra parentheses to be exact. And this is a 0 because it is the overflow, and this is a 1 because D2 is a 1. There we go. All right. So that's how I would answer the question, based on, what I have talked about in terms of, the grading. Basically, just have to have some kind of explanation, tell me why you think a particular bit is something. And the most difficult part of answering question number 1 is to use the chain of reasoning. We start with a known bit, and then we apply the rule to basically say, if we know T2 is 1, then we know this also has to be a 1. But since we already know one of the bits within this particular expression, we use it to rule out the one is coming from the sub-expression of not x1 and y1. Instead, the one has to come from not q1 and t1. But if we know that not q1 and t1 is a 1, that leaves us no other choices other than q1 has to be a 0 and t1 has to be a 1. So I would say the application of rule C in both times of this particular question would be the most difficult part of the question, is to really use that rule for this kind of purpose. So I'm gonna pause and see if you guys have any questions about the application of the rules. And meanwhile, we'll go ahead and check out question number 2. Question number 2 is actually kind of fun too. This one is a little bit different. Instead of using the borrow flag because it's not known, we're gonna do some other trick with question number 2. So I will for sure, answer question number 2. Question 1 is done. I mean, it's already full. Oh, you mean the other parts? You mean the boring parts? Okay, so let's go ahead and finish the other parts. The second part is to figure out the values represented. So this one is the unsigned representation of Q, and Q is 0, 0, 0 in this case. So we basically 0, 0, 0 in base 2 is 0 plus. Okay, so if you want to be specific, it's 0 times 1 plus 0 times 2 plus 0 times 4, which is also 0. That's the unsigned representation. The signed representation is going to be explained in this way. 0 times 1 plus 0 times 2 minus 0 times 4 is also a 0, because the most significant bit is indicating whether we should subtract 2 to the power of the relative to that position or not. So that is how we answered that question. And then we have T. T is a 4-bit number. It is 1111. So now we just say 1111 in base 2 is 1 times 1 plus 1 times 2 plus 1 times 4 plus 1 times 8. And that turns out to be what, 15? And the signed interpretation is very similar, and this is why it is useful to be able to copy and paste from your own document, because the only difference is what we do with the most significant bit. So we subtract the 8 instead of adding the 8, so now we have -1. Alright, the D is 111. So it's very similar to the other one. So I'm going to say 111 in base 2 is, and copy and paste, right? It's perfectly okay to copy and paste from your own document. So now we get to the 7, and over here 111 in base 2 is, and we just copy and paste most of it or all of it and then change the portion that we need to change. And instead of the plus, we have a subtraction. And that will give us -1 instead of 7. Alright, so that's the second part. Oh, okay. I didn't quite catch what was going on in the text channel. Alright, so part 3 is basically asking you, do you know how the p term is defined? Now, since it's emphasizing that we are looking at p as a multi-bit term, so now we just have to remember how p is defined. P is defined to be not x and y or y, not x or y, which in this case, if we look up, x is 101, so is y. Okay, so now we have the negation bitwise not of 101 in base 2 or 101 in base 2. This is a multi-bit operation, so that becomes 010 in base 2 or 101 in base 2, and that becomes 111 in base 2. G, on the other hand, is the bitwise not of x and y. So I probably should change this one. Instead of using the exclamation point, use the tilde symbol, because we are dealing with a multi-bit negation. All right, same deal over here. The negation of 101 in base 2, but this time it is ANDed with 101 in base 2. So now we have 010 in base 2 and 101 in base 2, and that becomes 000 in base 2. Now, for those of you who want to use the correct symbol, this OR really should be a bitwise OR, which in C and C++ is a single bar, and so is this one. So this is really just kind of when you want to be use the correct symbol. You can always spell out bitwise, okay? You can always spell out this one as bitwise AND. You can always spell out this one as bitwise OR or multi-bit OR. So all of those mean exactly the same thing. Bitwise OR, multi-bit OR just regular OR would also do. All right. So now we want to figure out what is T3. So that kind of goes back to the definition of T3 in the module. So you have to first spell out the borrowed look-ahead expression of T3. So go to the notes, find out what is T3, how it is completely spelled out. So let me do just that, right? Nope, this is from the wrong class. Got too many tabs already opened. That's why. And so that stuff is in binary subtraction, which also means, when you're studying, you can just kind of copy all the main equations already figured out and put it into one place. Then you don't have to do what I'm doing right now, because I am doing something. If I were to take this exam here, I would be wasting time right now looking for binary number subtraction, because I could have studied and put all the definitions in one place, so I can just look at it and go like, oh, okay, I know what T3 is supposed to look like. So there we go. And it doesn't really tell me what T3 is supposed to look like, but it does give me this thing here. But we also know, the notes here basically say that you just have to look at what is K and change all the K to T's, and then you have your definition. Okay, fine. So we're going to look it up too. Oh, Richard has done it already. Thank you, Richard. All right, so so I'm just gonna do the lazy thing because Richard has already typed it in. Okay, so we just copy and paste it here. So this would be bad, right? Because when during the test, Um, I'm copying and pasting from an outside source now instead of typing it in. So it's probably better for me to just kind of type it in. Oh, Control Z, Control Z. Okay, so I'm just going to type it in. So G2 or P2 and G1 or P2 and P1 and G0 or P2 and P1 and P0 and T0. Okay, there we go. All right, so now we look at this and go like, okay, what are these bits here? G2 is a false. Okay, so we end up with a false for the first part. And then we look at P2, P1, G0. G0 is also false, so that's going to be a false for the second conjunction. And then the next one, I think there's a missing term, G2. Oh, right, so the first one is G2. G2 by itself is a false already, so I forgot about that one. And now we're working with the last conjunction, which is P2, P1, P0. They're all ones, okay, so they are good there. And then T0 is also a 1, so we put an or 1 over here. So when you have at least one 1 in a OR expression, the entire OR expression is going to be a 1. So that would be the answer for T3. So there we have it. All right, so we got some questions coming in. I'm going to answer those questions before we proceed. Nope, there's no need to go any further because the question itself said, spell out the borrowed look-ahead expression and then substitute each P or G bit for the actual value and then evaluate it to find out the exact value. So we're good. How long do we have for the exam? We have the entire class period for the exam. So we have 80 minutes for the exam. I love those questions. Do we have a lab today? I will address that later. All right, so getting back to Ashton's point. So if you go all the way back to, I didn't explain this, so no fault on your own. Although you guys do have this test over the entire weekend. Um, so there are groups of questions. Let me know which group A, B, or C you want to use for grading. If there's no indication, I would use the first group that has any answer. Group A goes from Q1 to Q3, Group B goes from Q4 to Q8, and then Group C goes from Q9 to Q16. So yes, we do have 16 questions, but depending on whether you choose Group A, then you only have to answer 3. If you choose Group B, then you have 5. If you choose Group C, then you have, what, 8, I think. So there you go. Yeah, I think it is totally manageable because from Q9 to Q16, it is very tedious. Okay, you still have to kind of go through the explanation, so you'll be spending a lot of time typing, but not really a whole lot of time thinking because those particular questions have more known bits compared to Group C or Group B and Group A. So that is also why if someone has a perfect answer for Group A, that's going to be a 4.0 for the entire test. If someone has a perfect score for Group B, it is also going to be a perfect A. However, for Group C, because the difficulty level is really, really significantly lower, that means a perfect score for the entire group is going to be an overall grade of a B. So the trade-off is you go for easier questions and get a lower cap. Basically, there's a cap of what is the highest score you can get, or you can go for the more difficult questions where each one is more difficult, but there's no cap. Okay, people can get all the way to the maximum score for the entire exam. So it's a trade-off. People can decide which way they want to go. All right. So let me take a look at the chat channel. I got a lot of chatter from my other class right now, so it's kind of I have to really read the text message. I can't just look at the notification bar. All right. Yes. So if you choose Group A, you need to answer the first 3 questions. Now, it doesn't mean that you cannot just answer one and leave the other two unanswered. It simply means that your score will be 1/3 of the maximum. That's all that means. Uh, and then Terrence says so you can get only up to a B of the test if you do Group C. That is correct. I made that very clear to the class last semester that if they choose Group C, the maximum they can get is a B. Okay. MCAT. What is MCAT? Alright, so there's another point. So does Group A have less harder questions than Group? I'm guessing it's less difficult than Group A because the number of questions is increased. That is correct. So Group B has more questions, but each question has more known bits, making those questions easier to answer in a certain sense. Oh, okay, I see. So MCAT is for medicine. Okay. Yeah, so if you think the difficulty level is about the same between Group A and Group B, then obviously Group A is the best choice, right? Because you have fewer questions that you have to answer. So this is all subjective in a certain sense because different people look at these questions and rank them differently. Some people may look at Group A and say, this is impossible. I'm not even going to try. So instead, some people may decide, I know if I go to Group C, I'm going to cap out with a B. However, I have a pretty good confidence that I can answer all of those, and so I'm almost guaranteed to get a B, as opposed to if I go to Group A, I may not end up answering any questions, so I'm going to end up with a much lower grade. So this is for each person to determine. I cannot give you guys an equation so that you can say, okay, help me decide which group I should go for. I cannot do that. I can just give you, an option. Now, it doesn't even mean that, for this test next Monday or next Tuesday, I keep saying Monday, damn it. Next Tuesday, it may not even look like this. Okay, so, just treat your exam as a brand new exam and don't make assumptions. My suggestion is just that. Don't make assumptions. All right. If you do Group B and C, I'm going to invoke the first rule here. So you have to clearly indicate which group you want me to grade, and it's only one group. So you can answer all three groups, okay? If you don't tell me which group you want me to grade based on the instructions here, I'm going to use the first group, in this case Group A, that has any answer. Yep, see, I got a backup plan to a backup plan to a backup plan in terms of grading. I believe that would be all you would have to answer. Yes, so if you answer question 1, 2, 3 already, and you do not indicate which group you want me to grade, I'm going to grade Group A. I don't know why, but I can't see written solution in Google Doc. Oh, that's because I have not committed the answers yet. So I have to commit all to the answers. That's because I'm using this thing here, because I'm using suggesting. So all the changes is not put into the document yet. So what you guys can see is really just the question, but the answers are only suggested at this point. I think that might be a way to accept all the changes at the same time. Let me see. Is there a way to quickly accept all of the changes? Scroll back to the answers. Okay, how about I commit all the answers first? Okay, I can do that on the other side. All right, so that's one, Pretty sure there's a way to accept all of those suggestions at the same time. I think that's all. There we go. So you should be able to see all my answers now. So as I said, what's going to happen on next Tuesday is a document, with all the questions is going to be shared with you shortly before 9 a.m. And as soon as you get it, okay, as soon as you get it, you can start working on it. Also keep in mind that I'm sending all of these to your apps.losrios.edu account, which means you have to sign in to apps.losrios.edu before you can edit the document. Because I keep getting people saying, "Oh, give me permission because they are using a different Gmail account." So you have to sign in to apps.losrios.edu in order to answer these questions. Very good. And one thing, I'm not sure whether you guys can do it or not, but as owner of this thing, if you want to go back in time and go like, okay, how did TAC edit this particular document? You can show the history of the document. So this will show you step by step, blow by blow, minute by minute, how I made my changes in this document. So for those of you who want to kind of get back to the steps, how I edited the answer and so on and so forth, this is one way to do it. Kind of cool. In other words, revision tracking is built in to Google Doc. That has saved me, many, many times, because sometimes I make some stupid changes to my own documents and go like, what was that? Then I can go back in time and just say, okay, let's undo that. All right, so Richard has a question. We only have about 8 minutes or so left in the lecture, so I can use that to quickly go through the answer to question number 2. Instead of using the full format of the full explanation, I'll just go ahead and verbally indicate how to reason it out, just so that you guys know the answer to question number 2. All right, just to clarify, suppose you sent the test 5 minutes early. We can start. Yeah, you can start as soon as you get a test. So the way I unlock the test is the same order as the way that I lock the test. So that means it's not like someone is going to get ahead of the class, because they're the first person who get the test unlocked, and it's going to be the last person to get the test locked. So it's going to be the same order. All right. So someone is not even in the class. In the Discord, the student role is not there yet. Well, all right. So Jason said to submit the test, we do not have to do anything. Just have to wait for you to lock it. That is correct. So, I will not lock the test until the end of the test. So for this class, it's 80 minutes, right? So until 10:20, there won't be anything happening to the test, to the document. But after 10:20, the script will run. And so any moment after 10:20, you may get a test locked up. So don't count on, okay? Just don't count on having any time after 10:20 to continue to answer the questions. That's all I'm going to say is don't assume that you will have a lot of time, because you have no idea when the test is going to be locked up after 10:20. Yep, you don't have to save it. Isn't that great? I mean, this is Google Doc. Whenever you type, it's automatically saved in the cloud. Yep, so no need to save it in any way. All right. Okay, so we got 6 minutes left. I am going to work out question number 2, but not so much in a verbal way. I'm just gonna look at this and go like, okay, let's just do this quickly. All right, so we know the L flag is a 1, which means the exclusive OR between the O flag and the sign flag is a 1. So that leaves us, two possibilities. I'm gonna type, so because I cannot remember my own thinking if I don't type it out. So L equals to 1 implies sign exclusive OR with O is a 1, which implies one of two cases. Okay, it implies S is a 1, O is a 0, or S is a 0 and O is a 1. Okay, and that doesn't seem to be very helpful, but we can now look at each one and say, is that possible? Okay, so we'll take the first one. Okay, so we'll say if S equals 1 and O equals 0, what is going to happen? So if S is 1, that means D2 is a 1. Okay, that implies D2 is a 1, and because O is a 0, okay, so D2 is a 1, and so the only way to make overflow a 0 is y2 cannot be a 1, so y2 has to be a 0. So what is that going to imply? Is that going to be okay? So let's check it out. So we already know that x0 is a 0, 0 minus 0 is a 0, so that implies q2 is also going to be a 0. And because we assume d2 is a 1, so that means t2 is going to be a 1. So that implies t2 is a 1, and that would also imply what else? So what I'm trying to do here is to see if there's anything self-contradicting as I go through this line here. Oh, T2, sorry. T2, not T1. There we go. All right, so if I go in this line of reasoning, we got 0, 0. We got a 0 over here, and we got a 1 here, and then D is going to be a 1. So that implies D2 is a 1. So this is all self-consistent, and also, you guys are correct. Okay, Lao is correct that T3 is going to be a 0. It does not cause any conflicts. So I think this is going to be okay, but just to be sure, I'm going to test the other one too. So if S is 0 and overflow is a 1, what does that imply? Well, it is not possible. Okay, this is not possible because overflow is a 1 implies x equals to 0, y equals 1. I mean, okay, let's designate the bits. x2, y2, and d2 is a 1, and that conflicts with sign equals to 0. So we know it is not possible. So this combination, which is sign is 0 and overflow is a 1, is not possible. There we go. So now we have just locked down a bunch of bits. Okay, we locked down this one is a 0. We locked down this one to be a 0. This one is a 1. And this one is a 1. And also this one is a 1 as well. So this is what we have locked down at this point. And okay, I'm going to get rid of, not continue to use suggested mode. I'm just going to do the edit mode because otherwise you guys cannot see it. There we go. Okay. All right, so from here, what are we going to do? Well, we have this borrow bit of 1 and we have this bit of 0. So what we know is the subtraction between Q and T cannot possibly contribute to this 1 over here. So the only place that we can contribute to a 1 of in T2 is x1 minus y1. So now so yes, I'm kind of fast tracking the reasoning here. So 0 minus 1 results in a borrow of 1. And this is going to be a 1 because it is the exclusive OR between x1, y1. And this one is going to be a 1 because it is the exclusive OR between q1 and t1. All right, so now we only got one column left to work out. Oh, by the way, overflow is already figured out. It is a 1 because of that. Oh, sorry, it's a 0 because the assumption is working out. The other assumption does not work out. So there is that. So now we have to work out all of these bits. So what we know is we have a carry bit of 0 in column 1. So T1 is a 0, which means x0 minus y0 cannot have a borrow, and neither can q0 minus t0. But we know D is a 1, so that means we know that Q0 and T0 are not the same. One is a 1, the other one is a 0. So the only combination is this one here not to have a borrow in T1. So now that we know Q0 is a 1, we know x and y are different. One has to be a 0, the other one has to be a 1. But if x is a 0, y is a 1, then we end up with an overall borrow over here. So that would not work out. So the only way to make this work is to have x being a 1 and y being a 0. And there we have it. So we are running out of time, so I can't really just type out the whole thing. But that is the line of reasoning. T3 is a 1. Yes, T3 is a 1 over here. Yep, we got that. All right. T3 is a 1, not a 0. Because we have 0 minus 1. So you can do your scratch work somewhere, okay, but your explanation has to be typed in. I only did this part, like this quickly, because we are out of time, and I do want people to understand how we can get to the answer of question number 2. So that was why. Overflow has nothing to do with t. We determined that overflow is a 0 down here because that's the only way it's going to work out. The other way does not work out. And that's start with L being a 1, but t has nothing, absolutely nothing to do with overflow. They're defined differently. The B flag is T3. And that is determined only by the subtraction between x2, y2, and the subtraction between y2, t2. So it has nothing to do with overflow. Well, not directly. I mean, there are certain combinations that cannot be possible, but otherwise, their definitions do not relate to each other. So that means someone needs to go back to the definitions instead of using a don't use the common sense thing, to say overflow is the same as that or L is the same as that. Go for the mechanical definitions. Go for the bitwise definitions. Absolutely, Ethan is correct. You can use a different color, so that way it's easier for you to differentiate your answers from the question itself. That's going to help me too, so I would totally appreciate you guys if you use a different color. And I'm not colorblind in any way, so you can use any color you want. And then Darius said, I typed T3 equals to 0. Did I? That would be bad. Yep. Okay, I see. So that's my bad. My bad, totally. I apologize. There we go. Yep, that would make it a B answer, doesn't it? Because I mistyped. I get a C. No, I don't get a C because conceptually I did not make a mistake. All right. So I think we're good. So to answer an earlier question of whether we have a lab today or not, the answer is no, I do not have a lab. So I am expecting you guys to go like, woohoo, we don't have a lab. So that means we can use the next 3 hours to ask tech questions about all of these things that we have just talked about to get things clarified and so on and so forth. Right? Yeah, absolutely. So I'm going to be here for the next 4 hours. Remember, 3 hours for the lab and 1 hour for the office hour. So if you do have any questions, you can use that time to ask me about those questions. Okay, and you can use direct message too. Okay, you don't need to use the class, the server channel. You can just use direct message to ask me further questions. All right. And Vlad wants to go on. I can do that. I mean, since I'll be here for the next few hours, might as well just use it to work on the next question. Uh, the answer is yes to Terrence's question. I have a mechanically generated answer to everything, so I can give you that. Okay, it may not be the easiest thing to read, okay, but nonetheless, it has all the answers. All right, so let's get to question number 3, and I'm gonna be quick too because I'm going to give you the actual key to the entire thing. It's mechanically generated because when I wrote the script to come up with these questions, I also wrote the script to come up with the answers. So so it's very mechanical, but once you learn how to read it, it's actually pretty easy to read. Okay, so let's work on this one. And once again, I'm just going to do everything in place instead of spelling out everything that is actually needed in your answer, if these are your questions next Tuesday, which probably tells you that you're not going to get the same thing, right? Okay, this one is actually a whole lot easier because overflow is a 1 already, and we also know that the sign bit is a 1. So the only pattern that can make this happen is when we have a 0 here and a 1 over here. Okay, that has to do with how the overflow flag is defined. Overflow is a 1, it has 2 conjunctions, and we know that one conjunction is already false because x is 0, x2 is a 0. So we know the other conjunction has to be true, and when that conjunction that has 3 terms being true, that means we can lock down 3 bits, being x, y, and d. The x has to be different from y and d. That's basically what it boils down to. So given this, we know that T3 is going to be a 1, Q2 is going to be a 1, and knowing that this is a 1 and this is a 1, whatever is in between is going to be a 0. Alright, so I'm looking at the text channel. I'm a few minutes behind in the lecture, but I think I can already tell why the class is saying woohoo. I think in general, when I say there's no lab for the day, a lot of people are going to say woohoo, and they just kind of sign off. I'm kind of surprised that a lot of people are still on Discord right now, even on YouTube. That's a good sign. Don't get me wrong. This is a good sign. All right, so we have a borrow of 0 as T2, and yet we have a 1 over here. So that means this subtraction, Q minus T for column 1 cannot be generating a borrow of 1, and yet we know one has to be a 1, the other one has to be a 0. So the only way to make that work is to have this particular pattern. And the same applies over here, right? Because we know that Q1 is a 1, so that means x1, y1 cannot be the same. One has to be a 1, the other one has to be a 0. But we cannot have x1 being a 0 and y1 being a 1 because that will make t2 being a 1. So the only way that this is going to work out is a 1 and a 0 like this, x1 being a 1, y1 being a 0. So once again, we make use of the borrow bit, and we look at this and go like, we have a borrow of 0, and this time we're going to work with x, y first. So x cannot be a 0 because if x0 is a 0, then we have 0 minus 1, which has a borrow of 1. So the only bit that we can use for bit x0 is going to be a 1. That forces Q0 to be a 0, but because we cannot have a borrow in T1, that means T0 also has to be 0 because otherwise we end up with a borrow of 1 as T1. 0 minus 0 is a 0. And then we also want to answer what is the L flag. The L flag is the exclusive OR between the overflow and D2 in this case. So we have one exclusive OR with 1, which is 0. So there we go. I'm not seeing any questions. I can see a few people are dropping off from Discord, but most people are still here. All right. So, oh, that is a long text. I know in the mind map you explained how we could have any of the binary number comparison in our exam, but is it going to just stick to one scope for the whole exam, or will there be stuff from binary? Well, I haven't decided yet, Ethan. So I have not decided. I can only tell you what is the scope of the exam, but I cannot tell you uh, which part of the scope is actually going to be in the exam. So you just have to kind of be ready for the entire scope. That's kind of the general idea. I understand it is easier when you just explain than describe each action. I got a logic, but all this notation is confusing me. I'm not sure what notation. So are you referring to the notation that I was using in the answer of question number 1, the rules? The rules are coming straight out from the modules. I'm just extracting these rules from different parts of the module. You mean these rules, right? Yeah, rules A to F. These are all coming from the modules. I mean, I instead of using subscript, because I can't. Well, I can, but it's really kind of bothersome to use subscript. So instead of using subscript, I use the square bracket to indicate which bit I'm referring to. So other than that, I mean, these notations are fairly standardized compared to what I use in the notes, in the modules. All right, and can I give you 1 or 2 examples doing the same thing but in binary in addition instead of subtraction? I don't have anything handy to as an example right now. But remember what I said last week? If you have a study group, if you have a bunch of people to study together, you guys can do the reverse of what I have here. You start with a full worked out addition. And then what you do is to have each person in turn to remove 1 bit, but the whole thing still has to be fully resolvable and have every single bit to be determinable. Okay? And that is a reverse process to what I do here, and that would be a useful exercise. You basically just start with a binary addition, and then each person takes away 1 bit until the whole thing cannot be resolved anymore. I think last time I found out the game, the name of the game, is it like what was the name of the game? I looked it up last time. Yeah, Jenga, that's it. Or Yanga. I don't know the origin of the word. Yanga, that's right. Okay. So Yanga is the opposite of Sudoku. So the way the questions are being framed right now is Sudoku. Right? So this is like Sudoku, where you just have. Oh, let me take you to one that is okay, like that, like this. This is like Sudoku, right? You just have some of the squares filled in, and using the constraints, you have to figure out what the other cells are supposed to be. Except in this case, instead of using the rules of arithmetics, you're using the rules of binary subtraction in this case. So you can look at it that way because it's basically the same technique. You're basically trying to use logic to rule out certain possibilities, and then in the case of binary, it's easier because each cell can either be a 1 or a 0. In real Sudoku, it's a numerical value. So you got more choices that can fit into each square. That makes it a little bit more difficult. But in this case, it's either 0 or 1. The only thing that makes this one a little bit harder is because it is using the binary subtraction rules, which are not as well known and well practiced compared to arithmetic rules. So that's the real main difference between this and a actual game of Sudoku. But Yanga is the other way to do it. I mean, just start with a known result of a binary addition or subtraction, and then start to remove bits and go like, okay, if I take away this bit, can I still use the other bits to figure out what this used to be? So you keep removing the bits until you go like, okay, I think we have just removed the very last bit, because if I remove any one of these remaining bits, then we can no longer resolve the whole thing back to what it was originally. So that's an interesting game. I don't really study with other people when I was in college, so I don't really get to play that kind of game. You can do it yourself too. I mean, it's kind of like a solitaire mahjong, right? You're just removing the tile one at a time, and the objective is you want to remove all the tiles given the constraints of what tiles you can remove, from the stack of tiles. So you can do this, as a single person too. You just have to kind of play against yourself and keep removing the bits until you go like, okay, I think I have removed the very last one, because if I remove anything else, I would not be able to figure out the all the other bits anymore. So that's an interesting exercise you guys can do. But don't forget about the other stuff in the scope, because anything in the scope can potentially be in the exam. All right. I think it's another Y. It comes from Swahili word kujenga. Kujenga. Oh, okay. That's interesting. Thank you, Maddie. Can we use my rules like copy and paste? Well, if it is applicable, I suppose you can. So my answer to Darius' question is if my rules are applicable, you can use it. And if being the key word here. Jonathan says, in my opinion, Sudoku subtraction is easier than Sudoku addition. That is correct, because subtraction is not commutative, so it locks down values a little bit faster than addition. Because addition is commutative, which means 3 plus 4 is 4 plus 3, so you can exchange the positions of two values and it will still give you the same sum. But in subtraction, it doesn't do it, right? Because subtraction is not commutative. All right. Oh, thank you, Maddie. It means to build. That makes sense, even though in this case we are deconstructing. All right. So any other questions? I mean, we can work out some of the easier ones for people to kind of take a look at. Okay, what do you mean by easy? When I say easy, what does that mean? So we'll start with question number 16, and this is question number 16. All right, so let's work this out. Okay, so we have a borrow of 1 here, which means that one of these two subtractions has to contribute to this 1. But we don't even need to start there, because we got a 0, 1. So Q. So once again, I'm doing this, just kind of impromptu without writing down all the reasoning. But we know from, okay, I'm referring back to the rules. This is rule A. So from rule A, we know this has to be a 1. And then from rule B, we know this has to be a 0. So there's that. And knowing that this is a 0, we already know this has to be a 1, this has to be a 0, because that's the only way for D0 to be a 1, and that's the only way for D0 to be a 1 without having a borrow of 1 as T1. So if this is a 1, this is a 0, then this has to be a 1. This is from rule A. And now we have to work on this column. So because we have a 0 minus 1 here, this is guaranteed to be a 1. And since we have a 1 over here, now we have to decide which one is a 0 minus 1. And I think it is oh, there we go. I have not made use of the L flag, right? So the L flag is a 1, which means the overflow exclusive or with a sign flag here has to be a 1. All right. So that becomes the constraint, the real constraint for this particular question again. So we have two possible scenarios. So we have overflow being a 1. If overflow, okay, so let me emphasize, if overflow is a 1, that implies x2 is a 0, y2 is already known to be a 1, and then in this case, we also want d2 to be a 1. All right, so let's see if this works out, right? So if x2 is indeed a 0, so we have 0 minus 1, which is a 1, 1 minus 1 is going to be a 0, and it is conflicting with d2. So I'm going to say it further implies q2 is going to be a 1, but that implies d2 is going to be a 0. This is a self-contradiction, so this does not work out. So that means overflow being a 0 is the only choice left. Okay. So once we know that overflow is a 0, that's going to help us because now we can tell that this particular combination is not going to work. All right, so if overflow is a 0, then you can plug in, certain values. So if you plug in a 0 here, 0 minus 1 is a 1, 1 minus 1 is a 0, so that works out. If you put a 1 here, 1 minus 1 is a 0, 0 minus 1 is also a 1, that works out too. Huh, I must be missing something. Alright, so let me try that one more time. 1 minus 1 is a 0, 0 minus 1 is a 1, and if I put a 0 here, 0 minus 1 is a 1, 1 minus 1 is a 0. Huh. I have to be missing something. Let me undo all the changes. Would T3 help? No, T3 is not helping here because the question is between x2 and q2, which one is the 0 and which one is the 1? Because I already know one is a 1 and the other one is a 0. Both will contribute a 1 to T3, so T3 is not of much help here. So overflow can be helpful. All we know is overflow is a 0. So let me just put it here, just for the sake of looking at it. Okay, so if this is a 0, okay, if this is a 0, this is going to be a 1, and this is going to be a 0. So this particular bit pattern is consistent with overflow being a 0 because we don't have 0, 1, 1 as a pattern, or 1, 0, 0 as a pattern. So it's consistent with overflow being a 0 and overall borrow being a 1 because we have a 0 minus 1 over here. Now let me go back and redo this part. Instead of this, if I have 1 and then a 0 here and then a 1 over here, it is also consistent with everything that we have here. So it is still consistent with overflow being a 0 and T3 being a 1, and the rest of the bits are still consistent. So I must have missed something earlier. Would it be x being a 1, q being a 0, d being a 1, which is what I have here. So I cannot differentiate between the two cases because both are consistent with all the known bits. So that means I must have made a mistake somewhere. So the way that what I can do is I can undo the changes. Huh, interesting. So with more known bits, it is still an issue. It is possible that my script, somehow messed up. So That would be bad, right? Um, all right, so let me just undo my changes. All right, so this one I can keep. We just have to restore to this version here. And then we'll try again. All right. Oh, okay. We still have. I think there's still some more changes that I need to. Nope. Oh, oh, somebody got the original version. Okay, thank you. All right, so we got 110, and then we got question mark, oops, and question mark over here. And then we also got all question marks. And that's it. Okay. All right, so let me work this out again. Try to work this out again. All right, so this one is 1. There's no question about this. And because we have a 0 minus 1 from bit 1, this one is going to be a 1. There's also no question about it. 1 exclusive or with something is a 1. This one has to be a 0. There's also no question about it. Because D0 is a 1, so Q0 and T0 cannot be the same. And the only way for that not to have a carry of 1 is to have a 1 here and a 0 here. And because something exclusive or with 0 is a 1, that something has to be a 1. So this part, I'm pretty sure there's no other way to do this. So the only question here is using the overflow bit to help us, and also the borrow bit to help us constrain these 3 unknown bits. We know L is a 1. Okay. Okay, go ahead, Jason. So L being a 1 means the S bit exclusive with overflow is 1, which means S is a 1, O is a 0, or S is a 0 and overflow is a 1. And we already rule out the possibility. Okay, so S is 0, O is 1, causes self-contradiction. So we know that one already, and I'm pretty sure that the reasoning is correct, because if overflow is a 1, given that y2 is a 1 already, we have 0, 1, 1, which means the sign flag has to be a 1. So it has to be the other one. So sign is a 1, overflow is a 0, is the only remaining possibility. So using Sherlock Holmes logic, that has to be the case. Can we use the knowledge of what the number translates to from binary as evidence? Yeah, we know this is a 6, but we don't know. So we have to find out what x can be in order to end up with what d can be. The problem is we don't know this particular bit, and we also do not know this particular bit. So okay, I see what you mean. So you mean that we only got a few possibilities, right? Okay, so let's give that a try. Let's give that a try. So we know y can be seen as a value of 6. So x can be 1 or 5, and then d can be. That's a good way to look at it. Okay, Matty, that's good because I have not looked at it this way before. D can be 3 or 7. Okay, so now the question is which combination works and which combination does not work. So if x is 1, then we have 1 minus 6. 1 minus 6 using the unsigned subtraction is going to be, we normally know it as a, we normally know it as a -5, but -5 is the same thing as 3 with a borrow of 8. So it's 3 with a borrow of 8. So in this particular combination, x2 is a 0, and then d2 is a 0 as well. And q2 is going to be a 1. So it does work out, and we end up with a borrow. So the next one is if x is the other value, which is 5, and we have 5 minus 6, that means the d is going to be a 7 with a borrow of 8. So in that case, x2 is going to be a 1, d2 is going to be a 1, and then q2 is going to be a 0. So they both work out. Okay, so I might have a problem with the engine that is coming up with the questions, which is bad. I need to go fix that code. Richard says, I believe the L flag gives us a hint since it tells us that x is less than y, but that's only in the signed interpretation. Okay, so let's take a look at this in the signed interpretation. So in the signed interpretation, 1 minus 6 is going to be -5, and -5 has oh, okay, let me restate it. So what we know as a 6 is a -2. So 1 is less than -6 is not true. Okay. Okay, Richard is onto something because 6 is basically in the signed interpretation is -2. 1 is less than -2 is false, which means the L flag would have been a 0 in this case. So why are the bits not working out? Because I should have this should have indicated I should have arrived at a contradiction in this case. So we have 0, 1, 0. So overflow is a 0. Aha. Okay, gotcha. But the sign flag, so overflow is a 0, but the sign is a 0 too. Okay, there we go. Okay, so Richard is very, very good, Richard. I like that observation because what I forgot was if d2 is a 0, okay, so this further implies the sign is also a 0, which further implies the overflow is the sign which is a 0 exclusive ORed with the let's see, nope, take it back. The L flag is the sign flag, which in this case is a 0, and then the O flag is also 0. So 0 exclusive of 0 is a 0, and this is a self-contradiction. I forgot about this. Thank you. So Richard is correct. So this does lead to a self-contradiction, which means the other possibility is the only one left. So this one, let's check that too. Alright, so if we go with this particular interpretation, then we have the sign flag is a 1, which means the L flag is 1 exclusive OR with 0, and that is self consistent. There we go. Mystery solved. So what did Ivan say? Right. So Ivan is correct. Yep. Yep. So Ivan is correct all along. Very good. All right. Mystery solved. So Tech did not remember to use the L flag as a check of self-consistency. So I used the L flag to begin with to find out what are the possibilities, and then after I work out the bits, I did not go back to say, okay, is this going to conflict with what the L flag is given with? And I forgot to check that. That would be so. This would have been a if it's just for this part here, for figuring out this very last part, I think I would give myself a D in this case because I forgot to utilize the concept of using the L flag to check for self-consistency. Yes, so now you can tell all your other professors, Tech is self-rating himself as a D professor, specifically for this example. All right. But the point is, okay, this is a very good exercise. The point is we are looking for self-consistency. So we are using a chain of reasoning. Start with whatever is known, go through the derivation. If we can somehow come to a contradiction to what is already given to us, then that possibility, that combination of zeros and ones does not work out. And whatever is left that works out with no contradiction has to be the only answer left. So Matty contributes a lot to this conversation because she said, well, what if we used the interpretation of the value? Oh, that makes sense, right? Because when the L flag is a 1, that means the signed interpretation of the minuend has to be less than the signed interpretation of the subtrahend, which does not work out in this case. So that kind of pushed me to go like, okay, so that doesn't work out. That means I forgot about something about the L flag. And obviously, Ivan said, but I told you a long time ago it was the L flag. Yes, you did. I totally, kind of neglected to look at the text channel at that point. So, very good. You guys are definitely getting the material now. But it is the process, okay? The troubleshooting process, that is actually going to be helpful. All right, so do we have any other things that you guys want me to go over while on screen share mode? Can I fill in answers? Um, well, how about this? I'm gonna send you guys the key to the whole thing. I'm gonna upload the file, and it is the actual mechanically generated key. Unless you want me to explain it, so I can do that too. So let me go to exams. CISP310 1216. This is X1KW000. There you go. So you have, I just posted the mechanically generated key. So what you want to do is to download it and then open it in your browser. Then you'll be able to see the answer to all of the questions. All right, Lisa is typing something. So I think we are almost concluding uh, the full session for going over the practice test. All right. Oh no, thank you. I mean, thank you for staying here and for question number 16. I caught my own. You guys caught my mistake. Caught my omission of not working out the L bit based on all the other bits that we have worked out. To find that contradiction. Um, I'm not sure for which part. It depends on which part, Jonathan. Um, you mean for the first part? The first part, the mechanical generated answer is actually pretty long. The second part, I think the mechanically generated answer is pretty much the same as what I type. And then for the last part, it should be almost the same as what I type too. For question number one, I mean, I did not do it for the other questions. All right, you're welcome. All right, so I think we can stop the recording and also the screen share session. And one more person is typing. I'm gonna wait for two or more people. Okay, so that seems okay. All right. Yeah, so if you have any additional questions, you can bring it on Thursday too. I mean, I'm not going to stop talking about the practice exam. It's just that I'm not going to actively, bring it back up again on Thursday. Okay, so looks like we are ready. We have a few people still typing. I'm going to wait a little bit. So the lecture plan for Thursday is the continuation of the double precision floating point numbers. So that's what we're going to talk about on Thursday. And yeah, you guys have a good day too. And you guys can continue to work on this stuff here, work on some of the other questions, and I'll be here to help answer those questions. I'm not seeing anything. All right, is the exam going to be addition or subtraction? I think you should be equally prepared. In other words, um, going back to the scope of the exam, this is the earlier part. The earlier part of today's class, I kind of went over the scope of the exam. So I would just study for the entire scope. I mean, don't use the practice exam to limit your studying because there's no telling what I'm going to use in your exam. So all right. So I think people are signing off. I am going to sign off also from the